Hello. Hey everybody, how are you all doing? Welcome to what is today? Advent of Code Day 8. Those of you who tuned in yesterday will have witnessed the marvelous sight of me kind of banging my head against the wall for the better part of 2 hours. We got there in the end with 80,902 suitcases, which is obviously the correct solution to any real world problem. Um, but yeah, yesterday was a little bit tough. But I see a couple of folks saying today is a little gentler. So this could be fun. And as always, the idea is to wrap the whole thing up inside an hour. If it's done in like half an hour, we'll use the second half hour to do something fun. Maybe do it in JavaScript, maybe do it in Rockstar, maybe do it in. So I had a little look at the assignment today. It looks like we got some opcodes and things. So maybe we'll plug in something like a parsing expression grammar and see what we can do with that. But we've got to solve the thing first. So let's fire up there we go, Advent of Code 2020. Is Rockstar fleshed out enough? Rockstar is Turing complete, Galaxy Toucan. So in theory, well, I say theory, in proved mathematical theory, any problem that can be solved with computers can be solved with Rockstar. But it has, so that the recent innovations, there's a couple of things where array and list support is. I'm playing around with a bit of syntax. It has arrays now, and also one of the biggest things that was missing. Rockstar sticker on your laptop. You legend. Brilliant. Yeah, when Rockstar first came out, it was missing arrays and it was missing ways of doing like type conversions. So the only way to like turn numbers into characters was to basically write a massive function with like 255 statements in an if statement that would return strings. Which you can do, but it's not much fun. But now it has a cast operator which will turn numbers into Unicode code points and all kinds of things. So yeah, anyway, yeah, we'll come back to that later on. What we're going to do now is we are going to look at the day 8, and as always, we are going to start off by solving it in Rockstar. No, C#, not Rockstar. Now, those of you who tuned in yesterday, I was thinking about this a lot last night, because what we did yesterday is kind of looked at this thing, and the brief for day 7, for those of you who didn't look at it, was this very complicated set of inputs. And the difficulty we had was that the example that it doesn't compile to JavaScript. What Rockstar does is it compiles to an abstract syntax tree, which is represented by a JavaScript object, which is then interpreted by an interpreter written in JavaScript. So no, Rockstar, there is no program out there that you give it a Rockstar program and it'll give you a JavaScript program. There used to be a transpiler that kind of did that, but it's a couple of features behind now. No, the Rockstar interpreter is a JavaScript program that has a meta-circular evaluator that takes the output of the Rockstar parser, which is a parsing expression grammar. Anyway, let's go back to Advent of Code. We can talk about Rockstar later. So yeah, yesterday's was kind of gnarly because it had this very complicated, this entire scenario here, and then it says in this example 4. Now that's a single test case. That entire scenario is basically saying if we take this set of rules with this scenario, the answer is 4. Now normally with Advent of Code, the example gives you like half a dozen different things you can work with. Yesterday, not so much. So it probably took an hour just to work out how the hell you write unit tests for this thing, and then another half an hour to write some test cases and stuff. And it wasn't, a fantastically good way of approaching the whole thing. Give me 1 second. I have a pinging noise here, which might be important. Just let me take a quick look. So, This is the problem with being live on the internet is. Yeah, cool. All right. So yeah, we had this very complex thing with one test case, and so it took a lot of time to kind of flesh out the shape of the thing. And I was sort of thinking later about testing and unit testing and test-driven development and this whole, in what I call industrial programming. If you're writing code that is going to run in production for a long time, it's going to make money or make the world a better place, deliver value for somebody, and you're going to come back to it later and change it, tests are brilliant. on my Rockstar project, the only reason why I'm confident hacking around on that language is every single feature I've got has tests covering it. So even if it's been a couple of months and I can't remember exactly how all the bits hang together, I know that if I change it and the tests are green, then I haven't broken anything. Advent of code is kind of different. It's like yesterday I was thinking about it afterwards, and I was thinking if I had just started hacking, like taking a look at the problem, started throwing some stuff together, I reckon maybe this is kind of hubris in hindsight. I think it's probably like a 90% chance that I'd have got a working solution and it wouldn't have taken 2 hours, because so much of that time was working out how to deconstruct the problem into something that lent itself to unit testing. So I'm going to have a look at today's, but what I'm probably going to do is just kind of, because this is not code that is going to run in production. No one's going to, I hope, come back to my Advent of Code 6 months from now with an urgent bug fix for a VIP client, you know? It's supposed to be fun, and yesterday wasn't a huge amount of fun. So today I'm going to optimize for fun, and if that means that we kind of hack around a little bit and maybe don't write so many tests, then so be it. It's about enjoyment, and it's about kind of exploring the problem and figuring out what to do with it. So let's have a look at what we got for day 8. Your flight to the major airline hub reaches cruising altitude without incident, and while you consider checking the in-flight menu for one of those drinks that come with a little umbrella, see? Optimizing for fun. We've already got drinks with umbrellas in them. You are interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask if you can take a look. You narrow the problem down to a strange infinite loop in the boot code, your puzzle input, of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is a text file with one instruction per line of text. Each instruction consists of an operation, ACK, jump, or NOP, and an argument, which is a signed number like +4 or -20. We have to debug a game console before we get our drink with an umbrella in it. That's the wrong way around. That you should have drinks with umbrellas and then you start debugging the code. So what do we got here? ACK increases or decreases. So okay, so we're building a virtual machine, and our virtual machine has a single global value called an accumulator. Accumulator starts at 0. Okay. And accumulate ACK increases or decreases a single global value given in the argument. ACK +7 increments by 7. Okay, that's fine. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset. For example, jump +2 would skip the next instruction. Jump +1 would continue to the instruction immediately below it. Jump -20. So first thing that spins out as me as the simplest infinite loop in this program is just jump 0, because that's just going to jump to itself over and over again. And NOP stands for no operation. It does nothing, because clearly if you only have 3 instructions in your instruction set, NOP has to be one of them. If any of you have never read it, by the way, there's a thing floating around the web called The Story of Mel, a Real Programmer. It's an old hacker jargon file thing from the 60s, which is a story of a guy called Mel K who was writing poker programs to run on something called a Royal McBee, which used drum memory, like a rotating drum with a magnetic material on the outside that worked as a kind of mechanical memory system, like a predecessor to tape. And there's some amazing stuff in there about optimizing this thing by using the rotation of the drum to calculate the delay between instructions. And so that one actually used NOPs because it used no ops on the physical drum to move instructions to... Anyway, I digress. Story of Mel, a real programmer. Anyway, consider the following program. NOP, ACK, jump, ACK. So we are going to go... NOP is going to do nothing. Move to the next instruction. ACK is going to put 1 in the accumulator. Jump is going to jump 4, so that's +1, +2, +3, +4. Accumulator +1, accumulator is now 2. Jump -4, -3, -2, -1. Accumulator +3, 2, 3, 4, 5. Next instruction, jump -3, -2, -1, 0. Accumulator +1, accumulator is now 6. Remember that, 6. Jump +4, 5, 6, 4, 3, 2, 1. Accumulator +1 is now 7. Jump -1, 2, 3, 4. Accumulator +3 is now 10. Jump -3, 2, 1. Boom. Accumulator +1 is... yeah. All right, so that's all going to go round and round and round. Yeah, and it's never going to get to that instruction, and it's never going to get to that instruction. All right. Sweet. So, what do we need to do now? We need to... this is an infinite loop. We want a program that... So the moment the program tries to run any instruction a second time, you know it will never terminate. Kind of... Does it say there is an instruction just the address and the instruction, or is the instruction the address and the instruction and the instruction argument? There are no conditionals, but... Oh no, because jump will never jump. We can't pass the accumulator into the jump instruction, can we? The instructions are all hard-coded. Yeah, there's no conditionals. There's no branching yet. So this is a predecessor to the von Neumann stored program computer, as in the data, the program itself, is fixed. The data is mutable, but the state of the program cannot be mutated by the data. Flow control is not in scope for something that happens at runtime. So, okay, so if we ever hit a same instruction more than once, so immediately before an instruction is executed a second time, what value is in the accumulator? All right. That looks kind of nice. Looking forward to this. This could be fun. And yes, fun today is very much what we are going to optimize for. So let's create a new project. Let's do a console app.NET Core next. So this is going to go in day 8, and it is going to be day 8 code. There we go. Solution name day 8. All right, create that. So, yay, Visual Studio opened on a different window. Let me put that back over there so you don't all read my email while we're waiting for VS to wake up. There we go. Look at that. The joys of live coding. See ya, Galaxy. Have fun. All right, let me whack that up a bit. That looks. You can all read that? If it's too small, just shout in the chat and I'll make everything a little bigger. So, we have some input. We have the following program is there. So let's go with a const string program equals ding. There we go. So and the thing we are looking for is what happens when we run a program. So I'm gonna just sketch out. I think we need a type system, and I think we want a abstract class. We'll call it instruction. And instruction is gonna have an int, which is the argument, and that'll be gettable and settable. Now we could do this. I'm just looking at the ACK, the jump, those kind of things. We could do them as strings, or we could do them as instruction types. I'm gonna do them as instruction types because I said I was optimizing for fun, and I think that'll be fun. So now we're gonna have a class ACK is going to inherit from instruction. Yep, that's fine. And we've got a class JMP is going to inherit from instruction. And we've got a class NOP inherits from instruction. And then we are going to have a public, doesn't need to be public because we don't have tests and it needs to be visible. Class, oh, now this is fun because we've got a program over here. And we want a thing called program, and that's program, and that's program, so that's program. So let's call this Now, I'm pretty sure that you can call the program you want anything. No, that's horrible. I'm not going to do that. I think that the .NET runtime just looks for static void main, wherever that is in anything. But it doesn't matter. So I'm going to call this the advent of code program. Actually, I'm just going to call it prog. Main doesn't have to be in program, yeah, but what's the elegance? People expect main to be in program. If we create a class called program that isn't the program, That's gonna, each instruction also has a value, yeah, but they're all inheriting from instruction, and instruction has a private int, which is the argument that goes into that. So let's have a advent of code program. That'll do. So the advent of code program, public list of instructions equals new list of instruction. Yep, that's fine. And we'll put a getter and a setter on that. And we'll in here stick a public AOC program string listing. So this thing is going to parse the program listing. And we are going to have a method. So we actually want to run the thing, because if we run the thing, we're just going to dive headfirst into our infinite loop. Now, didn't Alan Turing prove that it's impossible to write a computer program that can take another second computer program and tell whether it contains infinite loops or not? Although I suspect that he was referring to the second program that's being analyzed being one that can contain conditionals, so its behavior is not known at parse time. So we actually, in this instance, are gonna... so that's instructions, that's that, and we are going to... Yeah, let's build the parser. Right, what have we learned from previous days? Var lines equals listing. First of all, we are going to replace any carriage returns with nothing. Then we are going to split it on /new line. Then we are going to select each element in that input. Split string options dot remove empty entries, and then we are going to select line goes to line dot trim. Listing, so replace that with that needs to be string, doesn't it? So let's /r with one of those, split that on a new line, that's fine, and give us that thing. Then we want this dot instructions equals lines dot select line goes to parse line, which wants to be a private instruction parse string line. Okay, there we go. Oops, bring that back up. What are we making? Hey, one line produce. We're making a virtual machine for running an instruction set that has 3 assembly instructions, and one of them is a NOP, no operation, which should be pretty easy. That can be replaced with a, yeah, that's fine, that's fine, that's fine. List.select that, .toList. That should be nice. Private instruction parse string line. So at this point, now the number here has always got a something on it. So var tokens equals line.split on a space. That is nice. Then we want to switch. So then var argument equals int32.parse tokens 1, which is the second thing in that pair, and then we want to switch on tokens 0, and that's going to give us our string. So case ACK, return new ACK. I need some constructors in here, or I can just do it donkey style, equals argument. That's nice. Let's make that public. Yep, that needs to be a string. Yep, that's fine. Case, that needs to be lowercase, doesn't it? Yeah, ACCJMP, okay. JMP, return new jump. Argument equals argument. Why not use the superior Rockstar language? We may do that in the second part of today's exercise. I'm sticking with C#. Because when I did try to do Advent of Code in Rockstar last year, so One Line Produce just asked in the chat why aren't you using Rockstar. Last year I kept finding things that Rockstar couldn't do, but because it's my language, I was like, I could add that feature. And so the like second and third day of Advent of Code, I took about 11 hours because I ended up adding all kinds of features to the Rockstar language just so I could do Advent of Code exercises with it, which, is kind of fun, but not really what we're optimizing for here. Case nop, return new nop, argument equals argument. There we go. Default, throw new not implemented exception. We cannot parse instructions of Boom. So there we go. We got a parser. Why is that complaining? Because my brackets are the wrong shape. There we go. Switch on that. That's all fine. Ooh, there's a little green line. This means ReSharper is about to go. Ah. Look at that. You can return switches. I didn't know you could do that. I love computing. You learn all these cool new things every single day. Okay, so what do we got? We've got, that's fine. But now what we need to do is to run our program. So parse is gonna give us, that's fine. So var prog equals new AOC program based on our program. I'm gonna rename that to be called listing. Okay, so there we go. Won't argument need to be at least protected gettable? Argument is public int get settable. It's you can do anything you like with it. So that should be okay, I think. So what do we want? So an ASC program equals one of those. That's the thing. That's actually, it was private. I made it public then. This is not a program. This thing we've got here, this is actually a computer. This is our computer. And our computer is initialized with a listing. And then that actually, we can even replace that with, yeah, you know what, that's fine. So we got a list of instructions, and we got a public int accumulator equals 0. And var lines equals that, list.instructions equals that. And then the last thing that I'm going to plug in here is this dot execution counters equals a dictionary of instruction and int. So what this is going to do is every time I run an instruction, I'm going to increment the value of this dictionary here, because that means that when I see an instruction, do we need an instruction pointer? Yeah, we probably do. That would make life easier, wouldn't it? Oh, look at that. I love all the moments. You see this? Accumulator and instruction, those two things there, they are the same length, which means my program lines up vertically and it looks like I did it on purpose. I'm a big fan of stuff like that. So, there's our execution counters. That is going to be a dictionary of instruction int. So that's going to be fine. And that, no, that's right. That can just be a lowercase int get set equals new dictionary of instruction and int. Why is that complaining? Remove initial, what? Because I initialize it inside the, so I can either initialize inside the constructor or I can give it a default, but because it doesn't depend on the listing at all, I'm going to put a default value in the property declaration over here, and then I don't need that in there. So that's going to load the instructions. That's all fine. That just needs to be a new dictionary of instruction and int. That is all fine. Public int run part 1. So I can tell you the story behind Rockstar another time. Uh, it is a good story, but this is not the time for that. So public int run part one. What are we gonna do? We are gonna say switch instructions instruction. And we are gonna say, what? No. That needs to be a square bracket. That needs to be round. So we're gonna use another nice pattern matching thing we got built into C#. Switch on that of that. Where's that complaining? Yeah, that's fine. Case ack. So what this is going to do is that if the instruction is an instruction of type ack, it is going to initialize ack with that for us. So if that happens, accumulator plus equals ack dot argument. And then, yep. Increment the instruction pointer and break. Okay. If it is a jump, then we don't do anything. We just say instruction plus equals jump dot argument break. And if it's case not, do nothing. There. That's nice. No, if it's not, we implement the instruction pointer, don't we? Yes, we do. So, switch instructions, instruction, but. So what this is going to run our program effectively. If we fire this thing up now, it is going to go straight into an infinite loop, because that's what the program they've given us actually does. And I want to... Well, true. Just run that over and over and over again. But we've got this guard clause that says the if we hit the same instruction twice in a row, we want to return the value that is currently on the accumulator and then stop, bail out. So while true, we are going to say if, what did I call it? Execution counters let me capture that in a variable, var inst equals instructions instruction, and then switch on inst. But in the meantime, if execution counters inst is greater than 1, return whatever is currently in the accumulator. So there we go. That is, what do we got? About 75 lines of code. Optimized for fun, zero testing, just kick the thing around and get a sense of the shape of it. That we don't need because the constructor will do that for it. Okay. So what I want to do now is I want to do prog.run part 1 and console.write line result. So, no, prog is a valid word. Damn it. How on what? Yeah. What kind of dictionary doesn't include prog? Oh yeah, I know, the dictionary of jazz. Right, let's run this thing, see what we get at the other end of it. So what we are expecting is this instruction should give us the value 5. This part is always a lot of fun, isn't it? Where you just click the big fat run button and see what you get at the other side of it. Boom, dayoutcode.nop was not present in the dictionary. I know why that is. It's because I have not initialized the dictionary to anything. I am going to So there's a bit of stuff. In execution counters instr, it's going, well, hang on, there's no nop, so I don't know what that is, so I don't know what to do about it. So I need to put a test in here that says if execution, I'm just going to call that counters. And I'm going to make it private because it doesn't need to be shared with the rest of the world, so that's absolutely fine. One of the fun things about Rockstar is the poetic literal syntax means you need to use quite a lot of 11 and 12 letter words, and so you find things going in your program lyrics which are words like topographic and troposphere and kaleidoscopic, so actually a lot of it ends up a little bit prog. Before you've even started. So yeah, we just got this thing of if the value doesn't exist in the dictionary. Now, I'd love to know if there's a type in dictionary, because in JavaScript, if you ask a dictionary for something that doesn't exist, it just gives you back something which is zero-ish. And then if you increment it, you get 1 and 2 and 3. So if counters dot contains key, I'm going to do this the old school way that I know how it works. So the instruction equals that, and if not counters dot contains key instructions, counters dot add instruction 0. Okay. And that's then going to say if count instruction greater than 1 turn. And finally, what we need to do is we need to say counters instruction plus plus, because every time we see it, we need to accumulate. Isn't it safer to use, Adam says in chat, it's safer to use the index of an instruction as a key in an execution counter. We are comparing instructions by reference here. And the reason why we're doing that is that our parser here is, even if we have the same code with the same thing, it is going to run new every time, and we're in .NET. These things are classes, so we're using reference equality by default. But Adam is absolutely right. It would be simpler. This dictionary here, we don't need to know the instruction, we just need to know its address. So that would... I'm going to run this and see if it works, just because I'm curious, but then we're going to implement that optimization, because that's actually quite a nice idea. 10, so it didn't work, so that's interesting. So why did it not work? We are expecting the number 5, aren't we? So what we want to do here is, there, greater than 1. That should be greater than or equal to 1, because if we've run this instruction before, greater than 0, this will give us 5 this time. There we go, 5. Okay, I'm confident that's working. Right, so let's just implement Adam's suggestion there, because I really like that. So dictionary of instruction and int actually becomes a dictionary of int and int. There's that, and now at this point the instruction is a pointer, so that, and if counters that and that. So now, instead of looking up the number of executions by the .NET reference identity of the instance of the instruction, we're just looking it up by the number, which tells you the address of that instruction in our program. And there might be a way of initializing. I don't like this. This is a little bit messy. So I'm gonna chop that line out, and what I'm gonna do over here is I'm gonna say this dot counters equals enumerable dot range from 0 to lines dot length dot count. Yep, that's a selectable. That actually, I'm going to stick a toList on the end of that, so it will force it to evaluate early so we can get the length. That's going to give us a list of integers, and for that I'm going to say toDictionary, and for each of those addresses, address goes to, so the key on each element in the dictionary is going to be address, and the value is going to be 0. So there we go. So now the constructor will give us a dictionary that has 0 is 0, 1 was 0, 2 is 0, which means instruction 0 has been called 0 times. Instruction with address 1 has been called 0 times. Instruction 2 has been called 0 times. There might be an easier way of doing that. That can go to a method group. That's nice. There we go. Let's run that, see what we get. Boom, 5. Correct answer coming out. Okay, so let's jump back over into our advent of code, get our puzzle input. Right, boom, right click, save as. YOLO time is indeed what it is. GitHub, advent of code 2020, day 8 code, input.txt. Save that in there. Bounce over here, Solution Explorer, input.txt. Properties, copy to output directory always. Run that, and var prog equals new computer file dot read all text input dot text and YOLO. The thing about YOLO, like I always found weird, is like if you only live once, surely that means you should be really careful. Like you don't want to die. Like, you know, if there was a, hey, you got 9 lives thing, it'd be like, yeah, it doesn't matter if you want to base jump off an aircraft carrier. You got 8 more lives. That'd be more like a YOLO kind of a thing. Right, let's run it, see what we get. Boom, go. Day 8 code, ship it. 1,586. Going once, going twice. Let's punch it into the internet and tell them what they won, Sammy. We've got 1,586. Submit. That is the right answer. You are 1 gold star closer. Woo! I need one of those plugins that does like rapturous applause and stuff. Right, part 2. One instruction is corrupted. Somewhere in the program, either a jump is supposed to be a NOP or a NOP is supposed to be a jump. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. Okay, so it terminates when it tries to run off the end of... I could get an air horn, couldn't I? Like, yeah. That was my best air horn noise, by the way. Changing exactly one jump or NOP, you can repair the boot code and make it terminate correctly. For example, consider, yep, that's fine. If you, yep. A jump plus 0 would create a single instruction infinite loop. I told you that's what would happen. If you change almost any of the jump instructions, the program will still eventually find another jump instruction. However, if you change the second to last instruction, the program terminates. Instructions are visited, so after the last instruction, the program attempt to run the instruction below the last instruction. Yeah, with this change, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly one jump to a NOP or changing one NOP to a jump. Hey, Cinziat, hello, welcome. So, so we could brute force this. Like, we could go through every single instruction in the program one by one. We could replace that instruction with a jump, replace it with a NOP, or replace the NOP with a jump, and run it and see what happens. I'm sure that there is a way of using some kind of static analysis to go back into the program and Sully, did you just put a clip on Twitch of me doing an air horn noise? Is that what you did? Let's have a look here. That's beautiful. Thank you. Thank you. Yeah. With viewers like these, right. So yeah, I think we need to brute force it. Yeah, we could do it with static analysis, but ain't nobody got time for that. So, so any instruction only lends itself to 0 or 1 forms of mutation. So I'm going to put in a thing here. I'm going to put in a public void mutate int instruction. And this is going to return a... So there's our computer. This is going to return a new... I'm going to stick another constructor, private computer on here which takes a list of instructions, and that is just going to say this dot. What I'm going to do is I'm going to write a mutate method where I tell it the address of the instruction to mutate, and it'll return a new computer with that instruction mutated if one of the valid mutations applies to that particular instruction. So private computer list instructions. So this dot instructions equals instructions. There we go. The rest is dictated by cannot convert type instruction to int. What? This dot instructions. Thank you very much. That's what we want. So computer takes a list. That's fine. So var new instructions equals instructions dot. Is there a clone? Or do we want to? Or what do we want here? How do we create a big shallow copy of a list in the .NET? Okay, this is dirty. There should be a better way of doing this. Select item goes to item. Dot to list. New instructions. Instruction dot mutate. So we need a mutate thing on here. So and that's abstract. So if we put a method on here, which is gonna be a virtual, because we don't want it to be overridable, instruction mutate, return this. That's fine, because if it can't be mutated, that can be public virtual instruction mutate, return this. But an accumulator, what were the two things we needed to modify? If it was a nop, we wanted to jump it, and if it was a jump, we wanted to nop it. Yeah, jumps to nops or nops to jumps. So mutate says if we have a jump instruction, override mutate, that is going to return new. A jump goes to a nop. Argument this dot argument base dot argument. Cannot resolve symbol add. Why is it trying to find a symbol called add? Weird. That should be. Yeah, thanks, Dave. Yes, it thinks I'm using an array initializer because I was writing JavaScript all night again. So override mutate on a jump returns that, and exactly the same. We just duplicate that syntax. Override mutate, and if it's a nop, we want to return a jump. Argument equals base argument. Okay. Base can probably come out. Yep. Which means that should now just, yeah, okay. Instruction would be cleaner with a constructor, wouldn't it? Plug that in, that instruction, and then CTR public int arg inherits from base of arg, and then doesn't do anything special, and jump has the same thing. Grab one of those, drop it in there, and nope. Yep. And nop has the same thing. There's that, which means new. Whoa, what did I do? I clicked the wrong thing. So there is That's nicer. Yep. And we just need to clean up the syntax on here. The accumulator does not support mutation. Yep, that's fine. Okay, that's all good. That's nice, that's nice. Constructed to protected because we don't instantiate them directly. That is gonna be a new ack on argument. That is gonna be that. That is gonna be that. Yesterday's stream should be on YouTube already, Louise. Although it's very, very long and not terribly entertaining. It's kind of the coding equivalent of watching Michael Bay's Pearl Harbor again. There was a good bit in the middle. So return circumscript arc argument. Let's make that arg because it's smaller. Yeah, there we go. Right, token split. That's fine. It disappeared sometime after the stream. Interesting. I will need to go and have a look. I wonder why YouTube has removed that. I certainly didn't tell them to. Yeah, no, sometimes it takes a little bit of time. Okay, so we've got all of our stuff there. Now, the last thing that we need here is that while true instruction thing there. So this is going to give us the value on the accumulator, but while true here is going to be an infinite loop. That's going to run off the end. So if the instruction is greater than 0, return the accumulator, but we also want a thing that says that if the instruction, I'm going to rename that to be pointer, because there are too many things called if pointer is greater than instructions.count, return accumulator. So that should give us our exit case. YouTube does not censor swearing as far as I'm aware, but the algorithms may have interpreted one of my comments about packing 80,000 suitcases as something to do with electoral fraud. I don't know. So yeah, we got 2 cases now. So this is our trigger case. This is how we bailed out. Now, we don't actually need to know the difference. What do you mean, which day, Gregor? It is, yeah, all right. Let's, this was day 7 yesterday they're talking about. Okay, so we don't need to know why we exited, because all the thing is asking us for is the thing that's in the accumulator. But we do need to know under which of these circumstances the program actually completed successfully. So we need a way of when we do the run part 1. So that's actually, we're just going to call this run. And we want run, and run is going to need to return something that tells us what was in the accumulator when it finished, and how we got there. But it's not even going to need to do that, because we can look in the accumulator after the program has completed, right? Because the accumulator on here is public. So all we need to do is to return a code which says whether our program was successful or not. So if the pointer is greater than the instruction count, we're going to return 0. There's a Unix convention that says programs that return 0 worked, and programs that return anything greater than 0 didn't work. So if our program returns anything greater than 0, it means that we had an infinite loop encountered. If it returns the value 0, it means that it completed successfully. Yeah, and Adam's just said that because that, I think, is the 24 seconds of YouTube latency manifesting itself. And he's now going to watch as I think, if I've understood his comment, he's going to go, oh yeah, that's exactly what was going on with it. Okay, so those can come out because 0 is the default value for ints in .NET because they're not nullable. So what I'm going to do now is let's just check Result equals prog.run and result dot so I'm just going to check whether any of those changes have broken it. 1586 was still my result from the first part of that, right? So that's still working, which is cool. But now we are going to throw the whole thing in a massive mutation engine. So, hang on, I see the problem. There we go. Look at that. Thanks, Chris. So, result equals probrun, prog.accumulator. So we are now going to say for int I equals, let's call it victim equals prog dot. I'm gonna do another thing. No, I'm not gonna do another thing. Am I gonna do another thing? Override instruction that. Override instruction that. No, I'm not going to do another thing. For int victim equals prog dot instructions dot, so that's going to go from 0. Victim is less than prog dot instructions dot count victim plus plus. Mutation equals prog.mutate victim. This is fine. Why is that complaining? Cannot assign void prog.mutate. Of course that needs to be a thing. Return computer mutate new instructions dot that, and then return a new computer with the modified instruction set as its only argument. That is gonna, yep. Okay, so mutation equals that. Var result equals mutation.run. That should be mutated result. Now, we could YOLO it at this point, and we could just go if mutated result equals 0, console.writeLine YOLO, and console.writeLine, and at this point we want the mutation.accumulator, I believe is what the program was asking us for, right? Else nothing. So if this works, we should get a single YOLO output from this program. We can take out that one there because that's our... what? No, come on. That's our prog. We're going to mutate it everyone in turn. YOLO when mutating instruction victim. Interesting. Oh, hang on. Yeah, I've done a stupid thing. That line there that initializes the counters needs to be in both places, but at the moment it is only reading it off the pointer equals instructions.count, assuming it's 0 indexed. I'll come back to that in a second. Hang on. If pointer equal, yeah. Well, technically greater than or equal because we might have a jump instruction that pushes the pointer off the end of the array. But equals 0 is the same scenario, isn't it? So yeah, the problem I've got is that this counters initialization here is I got two different constructors, and there's something in here which is now not being initialized properly. Instructions.count, instructions.that. Now, at this point, can I do that? Is that valid syntax in .NET? Because No, I don't believe it is. You can't have. Well, you can, but this syntax won't let it happen. We could do something absolutely disgusting, which is we could say that computer string listing actually wants to run, but I'm not going to do that because it'll be horrible. It is possible to have constructors that kind of redirect their behavior into other constructors, but you can't do it using what I thought we might be able to, which is that. So that instructions and that lines.count and that instructions.count, but that one there can actually be, yep, yeah. Actually, you know where to put this? A nice place to put this would be an interceptor on the set property for the instructions. We can come back to that later. All right, cool. That should work. Lines.count, instructions.count. It's not the most elegant code. Index was out of range. Instructions pointer. What is pointer? 641. Because the pointer can now be bigger than the program. I'm going to take that out. And I'm going to take that out. And I am going to put in the sanity check that we had at the beginning, which says if counters.contains key pointer. So if counters does not contain key pointer, in that case, counters pointer equals 0, or we can do a counters.add pointer 0. That kind of the syntax is equivalent. I think the add is more explicit. But that I think should run now. Out of range exception. Why? Because of course it's the thing we need. That needs to go at the beginning because we don't have any instruction. We've run off the end of our program. If the counter's pointer is greater than 0, return. No, not that one. It's that one. If we've run off the end of our instruction list, we return 0. Otherwise, find the current instruction. If we haven't got a counter for it, create a counter. If we have got a counter for it and it's greater than 0, return 1, which means infinite loop. Increment the pointer and then run the program. YOLO 703 on instruction 174, and there is exactly one of them. Answer, boom. Do we feel lucky? I might make the air horn noise again. If this works, I'll make the air horn noise again. There we go. Look at that, 1657, 58 minutes. To solve Advent of Code Day 8 in .NET. You're right, that was more fun than yesterday. And not a unit test in sight. I'm a terrible human being, and I should be cancelled and ostracized from the industry for not testing my code properly. But I did run it quite a lot, and we did verify the thing against their implementation requirements, right? So I'm just going to clean this up. I'm going to change the name of that to arg because it's nicer and smaller. And otherwise, I'm not entirely. That can be split out into its own class. That's fine. And that should be, yeah, that's just ReSharper complaining about stuff. That should have a capital P for its there. That should have a capital C because it's gettable, settable. That's all fine. That's nice. That I quite like. The .NET type inference, or rather type coercion pattern matching that we got going on there. That's pretty cool. That's nice. Yeah. I'm kind of pleased with that. So yeah, I was thinking yesterday about the whole unit testing thing, and I was sort of thinking, there's an argument that says, how confident are you that you could solve this problem, that you'll get lucky? How confident are you that you understand it and you can translate that into a working program? And what is the cost if you are wrong? And it's like, I don't know, air traffic control, odds of getting it right, 1%. If you're wrong, everyone dies. That's probably a good place to write tests. Advent of code, something like today, odds of getting it right, I'd say, I don't know, we had to kind of play around with it. I had to change a couple of things and I missed a few things earlier on. But I got to a working solution pretty quickly. So, I sort of said at the beginning I was pretty confident we could do it within an hour without writing any tests, which we did. 58 minutes to get the 2 gold stars. And the cost of failure there would be, have to go back and do it again. And maybe go back to the beginning and go, right, we need to start plugging in some testing around this because there's elements of behavior that no longer manually hooks all of the pieces together. But yeah, kind of happy with that. All right. David, you're up for doing a race on this. All right. I am absolutely up for that. So we'll pick a day. I'm going to try and do 4 p.m. every day this week. Next week, I just need to see. I got some events and stuff coming up. Shuffle it around a little bit. But let's figure out the logistics of doing a live Twitch coding race and see what we can do and who gets to the correct answer first. That could make things quite exciting. Split screen, same stream, split screen multiplayer. I'm wondering, what do you think the logistics would be if we had I need to think about this. I'm sure we can do something fun. Because we could do a split screen where each of us send a stream and we put them side by side. There's a co-streaming thing, or we could do something like a Zoom call and put that into OBS and get it at the other side. But yeah, let's figure out how to do a coding race on this, and we'll try some stuff out, and we'll do it on the stream. Right, folks, we're done. Question of the day: who are we going to raid? Who do we think would like an unexpected incursion of 35 people who've just been watching Advent of Code live in .NET? Let me have a look and see who's online at the moment. Who we got? We've got no, not that. Who's doing? Is anyone doing anything fun with Advent of Code? Anyone got a? So we got Eloise Game Dev is on doing some stuff. Let me see what else is live there. Day 4 of Honest Jam. Advent of Code 2019 speedrun. That looks like fun. You want to raid the Advent of Code speedrun? Actually, let's raid the Twilio quest. Nah, let's go Advent of Code. Let's raid Zapak. So /raid Zapak. There we go. See if that's gonna do what we want it to do. And 11 ready. 12. 3, 2, 1. Thank you for watching, folks. See you same time tomorrow for day 9. Take it easy. I'm going to go YouTube, see if I can find out where that missing video went. Have fun.